Today we're going to talk about sequences. Sequence, in layman's terms, is just a pattern of numbers. Now these can be a pattern from addition or a pattern by multiplication. We're going to take a look first at arithmetic sequences, which is just a pattern of addition. So here's the three examples. We are going to determine if we have a common difference between each of these sets of numbers. If so, then yes, it is an arithmetic sequence. From 12 to 8, that is going down by 4 units. From 8 to 4 is down by 4 units. 4 to 0 is also down by 4 units. Therefore, this is an arithmetic sequence, and it has a common difference of -4. The next one. This is 3, this is 5, this is 7. This is not an arithmetic sequence. It is not the same number. -6, -24. Again, it is not. Now, this is all jim and dandy. If I asked you what the next term was for number 1, for example, you would do 0 minus 4 and say -4. If I asked you the third next one, 0 minus 4, -4, minus 4, -8, minus 4, -12. That works great, but if I ask you what is the 100th term in that sequence, that'd be quite hard to do. So what we're going to do instead is the explicit form of an arithmetic sequence. What that means is we're going to have this equation where a sub n is your nth term. Or simply put, this is the one that you want. Okay? It is the value of the nth term. A sub 1 is the first term in your sequence. N minus 1, this is the number of the term. And D is going to be your common difference. Now take a minute, I want you to think about what this is saying. This is saying if I want to know whatever term a sub n is, I'm going to take the first number, and then I'm going to add whatever my ratio is. This is the D. I know I'm flipping the equation here, but oh well. My ratio, however many times after the first one. If you think of it this way, the equation should begin to make sense to you. So for example, if I'm looking to find the indicated term in the sequence below here, I'm going to be doing the 15th term. So I want to know what the number is at 15 terms. And it gives me a sub 1 is 7 and D is equal to 3. So the very first term is 7. My common difference is 3. And I'm going to be doing this 14 times. Because the 15th term is 14 terms after the first term. Okay? If you want to write it exactly the way it's written above, it would be A15 is equal to 7 plus 15 minus 1 times 3. But just because I'm showing you the way that I'm going to write it, I'm going to stay consistent because this is the way it works for me better. You can do this in your head or in the calculator, doesn't really matter, but you're going to get 49 as a final answer. I encourage you to pause this video and try number 2 for yourself. Okay, here's number 2. First term plus Common difference times 11, the numbers of terms after the first term. I'm going to get 19.6 as an answer. Before I do the applications, I want you to look at it and see if you can figure out how to set up the problem using this equation up here, and if you can find the answer. Okay, let's look at it. Each time a truck stops, it drops off 250 pounds of cargo. After one stop, its cargo weighed 2,000 pounds. How much does the load weigh after stop 6? Okay, let's look at the interesting and key information. Every stop is dropping 250 pounds. This is my common difference of negative 250 pounds. Stop 1 is 2,000 pounds rather, sorry. So that is going to be my end value, or where my end value starts. It's a sub 1, okay? And I want to know how much it weighs after the 6th stop. So I'm looking for a sub 6. I know my initial amount at the first stop is 2,000. I know that I'm going to be subtracting 250 from this 5 times. Why is it 5? The number I'm looking for, 6 minus 1 for the initial, is 5. And yes, that might have been procrastinating to do that math really quickly in my head. The answer, though, is 750 pounds on the 6th stop. Again, you can try this, but we're going to get started. You're looking for a sub 5. You have an initial of 4,300. You are increasing with a CD of 1,300. And you're doing that 4 times. 5 minus 1 to give me 4. This is 9,500. Yep, that's right. All right, recursive form for arithmetic. This is found to find the next term in a sequence. So if I give you the 82nd term, I ask you what the 83rd is, you can use this formula. A sub n, again, is going to be the nth term. N minus 1 is the previous. And D is your common difference. This really should be a common sense one. If I'm looking for a sub 5, and I'm given a sub 4 plus D. Okay, there's my example. And on the side, I say a sub 4 is 32. My common difference is negative 6. Well, if I want to go to the next term, it's going to be 32 minus 6. That's all we're doing here. Okay? All right. Probably should have put that at the top instead of closer to the bottom of the page, but oh well. Geometric sequences. A geometric sequence is again a pattern, but instead of adding to get to the next term, we're going to be multiplying. So I'm going to jump to the examples first. To start, that is. because I'm going to be asking what is the value of the 7th term in this example. While we're not going to be solving it yet, I do want to show you what the common difference is here. If I want to go from 15 to 45, this could be adding 30, but I'm going to look at the next one. That's 45 to 135 is not by adding 30. I'm going to try multiplication. So this is times 3. Check it on the next one. 45 times 3 is 135. The next one. Okay, we're good. So that is how I find an R value. The R is your common ratio. So a good way to remember the common ratio versus common difference. A difference is in adding and subtracting. A ratio is multiplying. Okay, so this is your common ratio. A sub n, a sub 1, and n are all going to be the same thing. Nth term, and I'm not writing the word term because I'm being lazy. First term, number of terms. Or of the term, to be more accurately, but we're going to leave it like this. All right, now to solve number 1. What is the 7th term? So I'm looking for a sub 7. I am starting with 15 as my first term. And I'm going to be multiplying this by 3. In my numerator, I want to be multiplying by 3 how many times? I'm looking for 7, so I'm going to be doing it 6 times. I use the calculator for this one. It's 10,935. If 12 is the third term and the ratio is 6, what is the first term? So I'm given the final. I'm given that this is it at the third term, which means I have a sub 1 times 6. This is my third, so it's 3 minus 1. So 12 is equal to my first term times 6 squared, which is 36. I'm going to divide each side by 36. My first term is equal to 12 over 36, or 1/3. Write the explicit formula for this sequence. My denominators, I am multiplying by 2, which means it is really multiplying by 1/2. Okay, I'm dividing by 2 to get to the next term. My common ratio is 1/2. My initial term is also 1/2. So, explicit formula. If I want to find whatever one, I'm going to take 1/2 times 1/2, my ratio 1/2, to the n minus 1 power. Okay, we are done. I do want to point out some other sequences, which is just Fibonacci. If you take the previous 2 terms, you can add to the next one. I think it's pretty fascinating. There it is. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 8 plus 5 is 13, and we're doing that forever. And we also look at the Fibonacci sequence because it is occurring in nature. It's called the golden ratio. A very abbreviated version. It's how the picture works. As a common amount, it is increasing by every single time. Okay. You are welcome to look that up. It's fascinating. We're not really using it, but still I did want to show you. All right, we are done for the day. I hope you have a great rest of your day.